guys, welcome to my channel. I'm LeetCode. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have a pretty interesting problem. So let's go ahead and read the problem statement, right? So the problem's called copy the list with random pointer, right? So it says a linked list given of left n, right? It's given such that each node contains an additional random pointer, which would point to any node in the list or null, right? All right, cool. So pretty much we have a regular list, right? A linked list, right? So we know that every node has a next pointer, right? That points to another node, right? And then every node does the same thing until you have the last node, which points to null, right? And then they told us that it also has a random pointer, right? That points to arbitrary places. So it could point to other nodes or it could point to null itself, right? So what we can do, right? So they told us, right, to create a deep copy of the list, right? All right, so we need to create a deep copy actually, you know what I'm saying? So a new list, right, that has the exact same nodes, right? Not the values of the nodes are the same, right? The exact order, right? And then they point to their corresponding next pointer, right? So and they point to other nodes as well, right? And then they're random pointer, right? So it says 7 is gonna have a copy, right? So every node is gonna have a copy pretty much, right? So it says the deep copy should consist of exactly n brand new nodes, where each new node has its value set to the value of its corresponding original node. Both the next and random pointer of the new nodes should point to new nodes in the copied list, such that the pointers in the original list and copied list represent the same list state, right? It says none of the pointers in the new list should point to nodes in the original list. Pretty much they're saying that, you know, so the new list that we're gonna have, right? So pretty much what they're saying, guys, we need to create a list, right? A deep copy of this list, right? So every node's gonna have a corresponding node in the new list, right? And it says it should be a deep copy of it, so meaning that should have the same values, right? So they should not be pointing to the same object. And they also said that none of the nodes in the new list, right, should be pointing back to any node in the original list, right? Pretty much, you know, they're saying to construct a list, right? And then the list should be almost the exact same thing, right? I'm saying so every node is gonna have a copy, right? So we know that every node is gonna have a copy, right? And then every node, right, should be pointing to exact same places as the original. So let's say 7's copy, right? Its next pointer, right, should be pointing to 13, but the copy of 13, you know what I'm saying, in the new list, what I'm saying that we're gonna have. Say just like 7's copy is random, is gonna be pointing to null, right? It's like 13 on then next, right? Its copy, right, is gonna be pointing to 11th, but the copy of 11, just like 13's copy, it's random, is gonna be pointing back to 7, but the copy of 7, guys, what I'm saying. So the way we're gonna go about solving this, guys, is gonna be very intuitive actually. So we're gonna be using this data structure called hash map, right? So a hash map allows us to have constant time access to data, you know what I'm saying. So to constant time lookup, I'm saying. So it's a very good data structure to use when you want to store stuff, right? So you're probably saying, where am I gonna store, right? So now we're actually going to store the copies of the nodes, right? So that when every node is gonna have a corresponding copy, right? So we're gonna store them in the hash map, right? So we could reference them pretty easily, right? So we're probably saying, all right, cool, we got the nodes. Okay, all right, we got the copies, right? So what am I gonna do with them, right? What we're gonna do, guys, is so after we have all the nodes, all the copies in the hash map, right? We're gonna loop through the list, guys, and reference the nodes accordingly, and just do the wiring pretty easily. You know what I'm saying? So we get 7's copy, right? 7's copies next, right, should be pointing to the that next original where originally was pointing, right? It's pointing to 13, right? But we don't want to point the copy of 7 to 13. We actually want to point it to 13's copy, right? So the structure of the hash map, guys, is gonna look like this, guys. What I'm saying, So we have a key and we have a value, right? And the key is gonna be the original node, right? And then the copy, the value is gonna be the copy, guys. What I'm saying. So 7, the original 7, right? Right, is gonna be pointing to a node, an object, right? Another object node, right? That's gonna have the same value as the original. I'm saying those represent the values. What I'm saying, but they're actually two different things, guys. What I'm saying, even though they have the same value, they're not the same object. What I'm saying, they just have the same value, guys. I'm saying, not pointing to the same memory location as the original. What I'm saying, that's why we create a new object to not reference this object. I'm saying, so it's a copy of that. It's how I create a deep copy, guys. I'm saying. So once we have that structure, right, we loop through and we get 7 copy, right? It's copy. It's that next, right? Should be pointing to 13, but we get 13's copy, right? We want the copy of 13, so that we only point to the copies, right? The copies point to other copies. You know what I'm saying? So yeah. So 7's that next, right? It's 7 that next copy points to 13, but the copy of 13, and the same thing, right? We do 7's random copy, right? It's copy, right? Now 7's copy, it's random, right? Points to null, right? Same thing. Just we go on to the next one, right? We do 13's copies next, right? Should point to 11's, but 11's copy, right? Same thing, and we do 13's copy it's random, right? Should be pointing back to 7. So hopefully you guys are able to understand what I'm trying to say. We're able to just get the thought process that I was trying to help you guys come up with, right? So right now we're just gonna go ahead with the implementation, guys. What I'm saying. So we do a simple check, guys. First, that's if the head is null, right? If head is null, we simply return null, right? And then now, guys, the next thing that we're going to do, right, we're going to have a cur variable, right? That's going to help us in looping through the list. You know what I'm saying? So that's going to be its job, right? And then we also, guys, remember that we talked about the hash map that we talked about, right? So we could reference the nodes pretty easily. You know what I'm saying? If we do map, go to new hash map. I'm saying, can't type today. What's going on? All right, cool. So we have the map, right? So now we're gonna so the first loop, right? We're gonna store all the copies of the nodes, right? So let's go ahead with that, right? So we do cur is not null, right? So we do we're gonna put the copy, right? So we're gonna use the key is gonna be the original node, right? And then the value is gonna be cur new, right? New node, right? So we do cur that val, right? So that's how we create a new object, guys. You know what I'm saying? So now that's how we got the deep copy of that node. What I'm saying? Yeah. So we pretty much create a copy of that node. What I'm saying, just by we get the actual data that's in there, which is the value. What I'm saying. So after we do that, guys, what I'm saying, we have to do curs, go to cur that next, right? This is how we move forward in a linked list, right? So if you guys don't know that, I guess you check out my linked list series that I have on this channel, right? So now the next thing, guys, after we store every node's copy in the hash map, right, we're going to do cur, right, is equal to head, right? So we restart, we go back to the head, right? So we restart. So now this time when we're looping through, right? This time when we're looping through, guys, we're going to, so we do the same thing. While cur is not null, we do, we're gonna do the wiring now, guys. I'm saying, so now the first loop is to just get every node's copy in the data structure, right? So now we're gonna reference them now to easily do the wiring. So we're pretty much done at this point, right? But this is the most tricky part, right? That you guys need to understand. So we do map that get, right? So we're gonna get, so we're gonna be referencing pretty much the copies of the nodes as we go now. I'm saying, so we do map that get cur, right? So pretty much, so now we restart, we're at 7, right? We said get 7, get the copy of 7, right? So that boom, we got the copy of 7, right? So we do map that get cur, get 7, right? Get the copy of 7 and its next pointer, right? Because on the first while loop, right, we just have the node and the hash map. That's all we have, right? So now that's when we're gonna do the construction of it, right? I'm saying, so we do now get 7s. So that's how we're gonna do. We're gonna construct the list now, right? So we do map that gets the 7's next, right? Get 7, right? Its next pointer, right, should be pointing to map that get, right? Get the, so now get the actual, so 7 is that next, right? Should points to 13, right? Now we're saying, all right, get, so my copy, 7's copy should be pointing to cur that next, which is 13, right? 13, but not this 13, right? But the copy of 13, you know what I'm saying? So it's a very good thing. See, I'm like, yo, get me. So I'm gonna be pointing to the copy of cur that next, right? This is a very good thing I want you guys to internalize. You know what I'm saying, that's the trickiest part of this problem. I'm saying, once you actually understand, I'm saying, like how hash map works and how we could reference stuff, it's gonna make a whole lot of sense. I'm saying, so we do the same thing, guys. So now we took care of that next. So we just, the 7's copy, that next, right, should be pointing to 13's copy, right? So now we're gonna do the same thing for the random, right? I'm saying, same logic. So we do get cur, right? Get that node, right? It's random pointer, right? Should be pointing to whatever node that is. What I'm saying, random. So we do cur that random. What I'm saying, right? Get the random in there. I'm saying, and after you do that, guys, remember to move forward. You know what I'm saying. So yeah, so let's say we move forward. We're at 13, right? We do 13's that next, right? So we do 13's copy its next pointer, right? So 13, we do map that get 13. So we get the, so we get 13, right? 13's, right? We do not this 13, but we want this copy 13, right? So we do its next pointer should be pointing to 11, right? But not that the actual 11, but 11's copy, guys. Now I keep saying it over and over again, just, you know, make sure that you guys understand, you know what I'm saying, key concept. So we do the same thing, right? We do 13's copy, right? Map that get 13, right? Get the copy 13, right? Not this 13, copy of 13. It's random, right? Should be pointing to the copy of the original random node, right? That I'm pointing at, right? So the original is 7, right? That's where 13 is pointing at. But we want the copy of 13. That's why we do map that get the copy of that node, what I'm saying? And then we just move forward there, right? So now then we're pretty much good. We just do map that return the actual copy, right? The head, not the original head. We don't return the original head, guys. We return the copy. You know what I'm saying? We map that get 7, but not this 7. Get me the, no, map that gets 7, right? The original, the key, right? Get the value, right? Which is a copy. Return that to me, and then now the 7's copy is the head of the new list. You know what I'm saying, because we just created a deep copy of the list, guys. Hopefully you guys are able to follow. So right now, let's just check if we pass the small test cases, guys. Perfect. You know, let's see if we pass all the test cases. Perfect, guys. We're able to pass all the test cases, guys. I want to thank you guys for taking the time to watch the video. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So I want to thank you guys for taking the time to watch this video, and I'll see you guys in the next one.